Welcome everyone. Today we want to share with you some of our knowledge about distributed tracing based on some simple example. I'm Patryk Matyjasek and I'm senior software engineer at Nike.
And I'm Michał Stachowski, senior DevOps engineer at Nike. So today's presentation, we are going to talk about microservices. What challenges do we have there? Then we will share knowledge about distributed tracing itself, how we can resolve some issues or challenges with microservices, with distributed tracing. Then we are going to compare distributed tracing and logging. We will show you some example and summarize everything what we've shared today. So let's start with microservices. And what is microservices? Microservice is, or also known as microservice architecture, is way how we can build complex solutions based on simple software components. Usually, we can also choose monolithic architectures where we've got just one service, which is hard to deploy, hard to maintain. With microservices, we can, resolve part of those challenges because we can, spawn single microservice application, single microservice instance close to the customer, so we can decrease latency, or we can scale based on observed resource usage and number of microservice instances, so we can, make the whole system a little bit more powerful, so our customers will be able to reach our service better. And last but not least, when we are spawning single software component, it's only responsible for just one thing, like in KISS. And where that component will fail in such a kind of mesh of services, then only part of system won't work or won't work perfectly fine. Sometimes part of that system could be, taken. Some kind of responsibility can be taken by some other services in our architecture. But it doesn't mean that microservice architecture is perfect for everything, because if monolithic architecture means that we've got just one component which is really challenging in terms of complexity, and the microservice architecture, move out the complexity on the level beyond, because instead of just one service, we've got a dozen of those services, and when our architecture will scale, this number of services will scale as well, and the complexity with it. That's one thing. The second thing, while we are increasing the number of requests that our customers can make, much more support tickets will be opened. So this also increases the complexity. It also, requires additional cost because our architecture could scale, and we can sometimes lose control over the number of resources that we've got. And it requires also the, powerful team, which is understanding how the architecture is working and how can some issues be resolved. So that lands us in the position where, let's say, some customer came to us and say, hey, our request works slowly, or our request is failing. In the number of services, and as you can see, this is how Uber microservice architecture looks like, at least was looking like this in 2018. How to start debugging? It's really hard to say where we should even start, but how to determine which service is responsible for our customers' issues. And I think that we can check that with distributed tracing itself.
Okay, so microservices increases the complexity of our solution, and it is more difficult to debug it, to observe our application, and distributed tracing is resolving that, adding some specific value, which is an unique ID that is added to our request, which is provided to our application. And as we can see, this is some simple example of this. We marked something which is named here trace parent. This is an unique ID which is called trace ID, and each request that has been sent to our application is getting the trace ID, which is an identifier for the whole flow through the whole application. And on the second part of slide, we can check how it is represented from the tracing side. Yeah, we have a trace ID and we have a spans. Spans could be compared to log entries because they are generated through our flow in the application, and they are packed with one single trace ID. Why this trace ID is very important? Because, for example, if our application is getting, for example, 10,000 requests per second, and 5% of them are a bit late, so we have a latency on some small number of those requests. And thanks to the trace ID, we are able to find the bottleneck and find the service that provides this additional latency. And what is distributed tracing giving to us? It increasing our level of application monitoring, because in our observability stack, mainly we have logs and metrics, and now we are able to add tracing for our distributed applications. As I said before, we are able to easily find the bottlenecks because it is easily represented by spans, because they are focused on duration in the whole stack, not on only timestamp. This allows us to debug our architecture. We can find if some of our services are not written optimally, and maybe we are using some additional API which is providing some latency to our application. And basically, traces are very similar to logs, but they are on a bit different level. In logging, we are able to log, let's say, every single line of code and put it into some log stream. Tracing is operating a bit level higher. We are focused on, let's say, service level. So we are logging how much time we spend in a single service during the whole flow of our app, of our system. And in comparison to logs, we can focus on three main features, which is a request flow. For logs, it is very hard to achieve, and we need to achieve it manually because we need to provide something like, let's say, trace ID, which is automatically done in distributed tracing. How to present latency? It is very hard for logging, because at first we need to find proper log stream for the service which took a lot of time, and then we need to count how many time we spent in this single service. In distributed tracing, it is very easy because we are operating on a request duration and time synchronization. For example, if we have many microservices which are logging data, so we have a log stream per each microservice. So we need to do some manual or semi-manual work to synchronize the time, to find what have been done before, what have been done after. In distributed tracing, this is also achieved automatically. And something about ecosystem of the distributed tracing. We've started with open tracing, which has been provided by Google, and it is a base for the next generation solution of that. In open tracing, we defined trace ID, we defined spans and stuff like that. And currently, open tracing is not in very active development, because most of focus has been moved to open telemetry, which is a more complex solution, because in open telemetry we want to have the whole observability stack in a single place, which includes logging, metrics, and traces. And tracing part is based on open tracing. And currently, OpenTelemetry is building up the community in which many companies are involved, like New Relic, Dynatrace, Datadog, or Sumologic. So they are developing solutions based on this, and also they are developing the whole observability stack. And the last thing is Jaeger, which defined JSON-based format of traces. It has been shown on one of the previous slides where we had trace ID and spans. This is defined by Jaeger, and it is very common solution, and that is used to graphically representing the distributed tracing stack. And now we can switch to our short example. We provide a very simple application which contains of REST client, which has been written in Python, some REST server, which is passing through requests from REST client to external API, and this REST server has been written in Golang. The external API is SpaceX API, which is exposing the data about some assets of the company. and we are storing some data in our database, which is Redis in our case. And the flow is very simple. Client is sending a request to the server. Server is storing this data in database and is passing through it to external API. Response from external API is also stored in database and returned to the client. And now we can see the view from the Jaeger. This is a trace which we can see that we have a different programming languages, different services here. So we can inspect our HTTP GET, which is sent to the server. We can find method, what response has been returned to the client, and many other things. Now we are moving to storing the data into database, storing the request data, and then our server is sending the request to external API, and we can see that is the longest part of our flow. So we can easily find that our bottleneck in our solution is some external service. So our code is written optimally, and the issue with our latency is provided by some external API. Yeah, we are returning. We are getting back the response from the server, and then this response is stored in Redis database. And very important thing, in this example, we provide only one single additional span. The rest of this flow has been achieved by technique called auto-instrumentation, because this investment in OpenTelemetry is related to developing the proper libraries that can be used. They have hooks to generate the spans, and it allows us to achieve this very easily.
Okay, so let's summarize a little bit what we've known so far. With what to keep in mind if we are planning to introduce distributed tracing in our stack. First of all, we have to remember that we have to remember about that we have modify our code simply. Even with auto-instrumentation, we have at least configure how our stack must be connected to the Jagger, for instance. That's the one thing. And we have to remember also about that all of components in our microservice architecture shall introduce distributed tracing capabilities as well to make it efficient. The bright side of it is a lot of open source third-party components already. We've got some integrations as for now, but internal components built in-house does not really common, and we have to influence on other projects to introduce those. And every single modification also provides additional dependencies, which we have provided with our service. And next thing is the performance, because if our application is badly designed, and we will decide to put in every single function additional span, then we will end in the first thing chaos in our trace, and secondly also it could decrease the performance overall of the whole system, which is opposite of our intentions. And last but not least, if we are introducing yet another component to understand better our whole architecture, by adding additional microservices, we are extending our microservice architecture, right? So in this case, we are also increasing the complexity of the whole stack. So our technicians must know how to operate with distributed tracing, must to check is the integration works correctly, etc. But if we will decide to integrate distributed tracing in our system, then we will receive the stack which we can observe from completely overview from the perspective where every single service is just like a dot on a map, to really every single detail, for instance, for single requests. And it's integrating well with standard logging, monitoring, alerting stacks, where because of single trace ID can be coupled with our logging. So whenever we will decide to, or whenever our customer will come and say, hey, my request is slow for some reason, or it doesn't work, we can simply track it through the trace ID which our customer will provide, and see where is the issue and what logs reveals the flow, right?
Okay, so distributed tracing is a very broad topic, and we managed to just scratch off the surface. But I hope our presentation will encourage you to, let's say, think about your distributed system, your distributed application architecture from the observability perspective, and you will think how to adapt and increase your observability with distributed tracing. Thank you. Now we are open for the questions. Yeah?
Where do you store your logs that come from the OpenTelemetry? Do you have an in-house solution? Is it a part of one of the tools you mentioned?
It depends, because we can store those logs in some observability vendors storage, as I said, like Dynatrace, New Relic, or SignalFX, or stuff like that. Or we can also provide some in-house solutions for that, like Elasticsearch or Kibana.
At Nike, we are usually got a team which is responsible for such kind of thing, which is delivering us either Jagger and Elasticsearch as an endpoints, depends on what we need.
Can you turn this tracking on and off so you have best performance for the client, but when the issue comes you can just turn it down, slow the system a little, but track it, or is it always on?
Usually whenever you are trying to integrate with distributed tracing, if you will not provide a config, then it's turned off. But I would recommend in that situation to better design how deeply you would like to receive the knowledge from such kind of system. Because the problem is not with, in my opinion, with the distributed tracing itself that, hey, it's lowering your performance. No, it's still, as you can maybe, I'm not sure, have you seen that, but the requests are stored in microseconds, so it's not a big deal. The problem is if your application is looping sometimes and is trying to, make some kind of storm of those spans into your system.
Yeah, the ideal solution for that is, as I said before, generate spans only per single microservice to, let's say, to check how much time we spend in this particular part of the solution, and then we can move to logs to debug it more deeply. Yeah. Yeah.
What's the estimated performance degradation like in terms of P90, like maybe certain value?
It is around 3 to 5%. And based on my experience with that. Yeah.
What are usually next steps when you find the slowest part?
It depends on your solution. If you have, let's say, this model that I've mentioned before, that you have tracing and you have a logging system correlated to trace ID, it is very easy to switch to, for example, to your Kibana dashboard and check what happened during your request in this single part. Or also you can use some external vendors that are let's say integrating it into single place. Yeah. So mainly it is analyzing the logs. So the distributed tracing is not let's say problem solving as a single solution. Yeah. So you need to still have both of them, logging and distributed tracing. Okay, if there are no more questions, I think we can finish. Thank you.